Chapter 16. Section 3. 10. Plastic clay formation. In conformity with the nomenclature of Messieurs Cuvier and Brognard, a principal division of the tertiary formations, consisting of various beds of sand, clay, marl, and gravel, is distinguished by the name of plastic clay, argile plastique. An attentive examination of the general points of resemblance in the physical characters and organic remains of these irregular alternations above the chalk leaves no doubt of their being members of a series of nearly contemporaneous depositions, intermediate between the formation and the London clay. A fine series of beds belonging to this division occurs at Castle Hill on the western side of New Haven Harbour, lying upon the chalk cliffs, which are there about 50 feet high. The summit of the hill is broken and rugged, and its appearance differs so remarkably from the smooth, rounded surface of the surrounding downs, that the geologist, even at a distance, would suspect the existence of strata of a very dissimilar character to any that exist in its vicinity. Towards the sea it presents a steep declivity, having numerous shelvings and fissures, occasioned by repeated slips of the strata. On the eastern brow, an ancient circular entrenchment still remains, and from this point the beds extend about 1 mile westward, where the chalk cliffs are covered only by a thin layer of ochroceous clay and vegetable mold. These deposits were first noticed by Henry Warburton, Esquire, F.R.S., Secretary to the Geological Society, etc., and have subsequently been described by Mr. Webster and Professor Buckland. Section of the strata at Castle Hill, near New Haven, beginning with the lowermost deposit. See Tablet 6. (1) Chalk with flints. Thickness 50 feet. 2. Ochroceous clay containing hydrate and subsulfate of alumine and crystallized sulfate of lime, about 1½ foot. 3. Breccia of green sand and chalk flints, the latter covered with a green and ferruginous crust, 1 foot. 4. Sand of various shades of yellow, green, and ash color, 20 feet. 5. Blue clay with marl of a sulphur yellow color, including large crystals of sulfate of lime with fibrous and foliated gypsum, 20 feet. 6. A seam of surturbrand or coal, about 6 inches. 7. Indurated reddish-brown marl, the lower part slaty, containing impressions of leaves and casts of Cerithia, Cyclades, etc., a few inches. 8. Blue clay, containing an immense number of shells, chiefly of the genus Cerithium, teeth of a species of squalus, etc. This bed is traversed by a seam of pyrites, a few inches thick, containing casts of Cerithia. 9. Blue clay with broken bivalve shells, apparently of the genera Cytherea and Serinae, 10 feet. 10. A bed composed almost entirely of oyster shells held together by an argillaceous cement about 5 feet. 11. Diluvium, consisting of yellow and fawn-colored sand, with pebbles, the latter evidently formed of broken chalk flints, rounded by attrition, from 10 to 15 feet. The ochreous clay, number 2, contains the substance that has rendered Castle Hill so interesting to the mineralogist, the subsulfate of alumine. As this mineral is peculiar to Sussex, or at least has not been discovered elsewhere in England, a particular description of it must not be omitted. Hydrate and subsulfate of alumine. British Mineralogy. Tablet 499. Annals of Philosophy, Volume 2, page 238. This substance is embedded in a layer of ochreous clay that lies immediately upon the chalk. The bed is situate nearly midway between the summit of the cliffs and the sea-shore, and therefore cannot be examined without much difficulty and exposure to considerable danger. The first specimen of the subsulfate was discovered by the author among some gravel that had been brought from Newhaven, and was lying in a wharf near Lewes. A few months afterwards, Mr. Webster, in a geological excursion along the Sussex coast, collected a specimen at Newhaven. This was analysed by Dr. Wollaston, and found to consist of alumine, in combination with sulphuric acid, and a small proportion of silex, lime, and oxide of iron. This mineral occurs massive in veins and in tabular and tuberose masses, the former frequently attaining several feet in length, and the latter exceeding 3 or 4 pounds in weight. It appears to have been of stalactical origin, and is supposed to result from the decomposition of iron pyrites, and the reaction of other substances. As the superincumbent strata contain all the elements necessary for its production, it probably has been introduced into its present situation by infiltration. When pure, it is perfectly white, but is generally more or less discoloured by an intermixture of yellow clay. It is dull and opaque, with an earthy fracture, and yields to the knife. It is infusible at 166 degrees of Wedgwood, but fuses rapidly when exposed to the stream of the hydro-oxygen blowpipe. The result is a pearl-white translucent enamel, a partial combustion taking place during its fusion. According to Strohmeyer, it consists of alumine, 30, sulphuric acid, 24, water, 45. Crystals of gypsum are frequently decimated through the masses of alumine, and the two substances enter into various states of combination, sometimes giving rise to specimens that are semi-translucent. Chalk flints, indurated ochreous clay, indurated ochreous clay, and other extraneous bodies are also occasionally enveloped. From the recent experiments of Dr. Clark, it appears that the purer masses of aluminite are destitute of sulphuric acid and consist simply of water and aluminous earth. Hence a suspicion has arisen that the sulphuric acid in the examples analysed by Strohmeyer and Dr. Wollaston may have originated from the presence of gypsum. This, however, is not the case, since in many specimens it is evident that the sulphate of lime has been decomposed, and the sulphuric acid entering into combination with the alumine has formed a true subsulfate. The hydrate occurs in friable masses of the colour and consistence of magnesia. It adheres to the tongue, and may be reduced to powder between the fingers. In this respect it differs from the subsulfate, which possesses considerable hardness, and is susceptible of a fine polish. The flints or pebbles composing the breccia, number 3, are characterized by their green and ferruginous crusts. This appearance is so peculiar that it frequently serves to identify the situations formerly occupied by the breccia. The flints or pebbles composing the breccia, number 3, are characterized by their green and ferruginous crusts. This appearance is so peculiar that it frequently serves to identify the situations formerly occupied by the breccia, even where the stratum itself has been broken up and destroyed. These pebbles are scattered over the ploughed lands on the summits and slopes of the downs, near Tarring, Piddinghoe, Falmer, Stanmer, Bormer, and many other places in the vicinity of Lewes. I have also detected them in the alluvium of the interior of the country. Water-worn fragments of the breccia occasionally occur in similar situations. Some of considerable magnitude may be observed lying bare in the fields near Brighton Church, Goldstone Bottom, and Falmer Hill. The selenites or crystallized gypsum of number 5 occurs in flattish crystals from 6 to 8 inches long, which are generally in the form of oblique parallelepipeds or of rhomboidal prisms. The fibrous gypsum is deposited in veins in the marl. The foliated variety occurs in large tabular masses, composed of thin laminae, and is frequently coated with a coaly substance. The surturbrand or coal, number 6, appears to be analogous to that of the Paris Basin, Corfe Castle, and Alum Bay. It also resembles the surturbrand of Iceland. Some specimens are exactly similar to the Bovey coal. Rolled masses of this substance are frequently found on the shore at Brighton, and were formerly so abundant as to be used for fuel by the poorer inhabitants. They are provincially called strombolo, a corruption of strombolin, stream, or tide balls, the name given them by the Flemings, who formerly settled in that town. The use of this substance was prohibited on account of the very offensive smell emitted during its combustion. It was employed by the late Dr. Russell as a fumigation in certain glandular complaints, and it is said with decided benefit. The organic remains found in these deposits are the following. 1. Wood. A small block of wood, with the ligneous structure well preserved, has been discovered in the sand of the diluvium. Number 11. 2. Impressions and remains of leaves. Tablet 8. Figures 1, 2, 3, 4. Impressions and remains of leaves. British Mineralogy, Tablet 500. The specimens figured in Tablet 8 and in Mr. Sowerby's British Mineralogy were collected from the red marl, number 7, but although considerable diligence has been used to add to their number, our researches have been unsuccessful, nor can we discover the precise spot from whence they were taken. They are peculiarly interesting, as they afford an example of leaves and shells embedded in the same stone, an association but rarely observed. The impressions in figures 1 and 4 are thought to bear some resemblance to the larger foliage of Plantanus orientalis. This opinion may probably be correct so far as regards the genus, but the characters of the leaves appear to be too imperfectly developed to admit of the species being identified. Figures 2 and 3 differ in some respects from those above described. The upper beds of the calcaire marine grossier of France also contain vegetal impressions, but those represented in the Essai sur la géographie minéralogique, Plate 2, Figure 1, do not correspond with the fossils under consideration. The French specimens are supposed to belong to a species of Nerium. However this may be, it is obvious that, like those of New Haven, they cannot have belonged to any marine plant, although they are now embedded in the midst of testaceous remains decidedly of marine origin. 3. Mr. Webster mentions that H. Warburton, Esquire, discovered in the marl at New Haven leaves precisely similar to those figured by Cuvier, and also a fruit of a species of palm, with the vegetable fibers quite distinct. 4. The casts of shells in the specimens figured belong to the genera Cerethium, Unio, and Cyclus. The species of the latter resembles the Linnaean Mactra solida, or subtruncata, which is also found abundantly with Cerithia in the blue clay at Woolwich. 5. Cerithium funatum, Tablet 17, Figure 4. A conical elongated shell with two obtuse, crenulated, transverse ridges on each volution. It consists of 10 or 11 whorls, and is seldom found perfect. It occurs in immense quantities in the blue clay, number 8, and is sparingly distributed in the oyster bed, number 10, and in the red marl, number 7. 6. Cerithium melanoides, Tablet 17, Figure 3. Turreted, whorls convex, longitudinally undulated, transversely carinated, carinae tuberculated. This elegant species is found in the same stratum with the above, but is easily distinguished by the sharp, tubercular, carinated ridges with which it is ornamented, and with the longitudinal depressions between the tubercles. It is comparatively rare. 7. Helix, Tablet 18, Figures 19, 20. The delicate little shell figured in the plate referred to was found by Colonel Birch of Bath in the blue clay, number 8, of Castle Hill. The mouth is filled with clay, and the specimen is too fragile to permit its removal. The surface is perfectly smooth, the spire elevated, the volutions are 3 in number. It has much the appearance of a freshwater shell. 8. Cytherea scutellaria of Webster, Tablet 25, Figure 2. This fossil is from the blue clay, number 9, which is almost entirely composed of broken bivalves, apparently of the genera Cytherea and Cycles. A perfect example is exceedingly rare, and I have not yet been so fortunate as to discover one, the shell represented being the most entire of any in my possession. I believe it is this bivalve that Mr. Webster has designated by the name of Cytherea scutellaria. It very nearly resembles the Cytherae bombay of Lamarck, des Marnes supérieures de Gypse. 9. A species of Serene, This shell was also found in the blue clay, number 9, and is remarkable from its being the only decided instance of a freshwater shell that has been discovered in that deposit. 10. Austria. The bed, number 10, consists principally of a broad, flat species of oyster, presenting nothing peculiar in its form or appearance. Another species is sometimes found, in which the upper valve is nearly flat, and the lower one very convex. This shell is precisely similar to a specimen in Mr. Parkinson's cabinet, marked Austria vesicularis. 11. Tooth of the Squalus mustellus. This specimen is from the blue clay, number 8, and perfectly resembles the teeth of the recent fish. Of the strata above enumerated, numbers 8, 9, 10 are considered by Professor Buckland as analogous to the plastic clay beds of Woolwich. Numbers 7, 8, Plate 8, Geological Transactions, Volume 4, which contain also the same species of Cerithium and Cyclus. Number 4 of Castle Hill is the ash-colored sand of Woolwich, in diminished thickness. The breccia number 3 corresponds with the Reading oyster bed, which, though inconsiderable in thickness, seems constantly to occur immediately above the chalk, although organic remains have been noticed in it only at Reading. Between Castle Hill and Seaford, a flat alluvial tract intervenes, through which the Ouse flows into the British Channel. To the east of this marshy plain, the perpendicular slopes in which the downs terminate are covered with a cap of fawn-coloured and greenish sand, with rolled blocks of chalk and flint pebbles. An excavation on the side of the hill, near the road leading from Newhaven to Seaford, exhibits a good section of these deposits. The rolled pebbles and sand occupy about 15 feet of the upper part of the bank, and lie in a hollow or basin of chalk rubble. And wherever the chalk is accessible to observation along this margin of the downs, it is invariably in a broken and ruinous state. At Chimting Castle, about half a mile to the east of Seaford, the upper part of the cliffs is composed of a bed of sand, about 50 feet thick. Here a stratum of the ferruginous breccia, previously mentioned, is seen in situ, lying beneath the sand and immediately upon the chalk. The sand is of a fawn colour, passing into olive green. It contains numerous irregular veins and concretions of mammillated ironstone. The pudding stone or breccia is precisely similar to that of Castle Hill, with which there can be no doubt it was once continuous. The flints that compose it present the same characters, some being rolled, others angular, and all of them either of a dark green or yellow colour externally. The bed of breccia in some places is nearly 4 feet thick. These deposits extend eastward about half a mile, and disappear near the signal house. They dip to the west at an angle of from 10 degrees to 20 degrees. Eastward of this place, the chalk has only a covering of ochreous clay and vegetable mould, and, with the exception of the blocks of breccia at Brighton, etc., previously alluded to, and a few insular patches of olive-green sand in hollows of the chalk at Piddinghoe, I am not aware of the existence of any other decided examples of the plastic clay in the south-eastern part of Sussex. In the western division of the county, Professor Buckland observed a red variety of plastic clay in a small valley at the village of Binsted, 3 miles east of Arundel, and also on the declivity of the hill by which the Binsted and Chichester road descends into Arundel. The country around Chichester has a foundation of chalk, with a subsoil of fine red gravel, and pebbles mixed with sand, loam, and chalk rubble. Furrows and wells in the chalk, filled with these materials, are commonly observable in the quarries near that city. On the opposite coast of France, strata corresponding with those of Castle Hill and Chimpton Castle occupy the same relative position. In the perpendicular cliffs under the lighthouse of St. Margaret, to the west of Dieppe, the following beds occur. 1. Chalk. 2. Sand and sandstone in thick beds, containing concretions of the same substances. 3. Plastic clay, impure and containing lignite much charged with pyrites. Also oysters, cerithia, etc., both in beds and irregularly disseminated. 4. Alluvium. These deposits Monsieur Brongniart considers as identical with the beds of the plastic clay formation in many other parts of France, particularly at Marly and in the Soissonnais, where similar organic remains occupy strata disposed in the same manner and identical with those near Dieppe. In the preceding sketch of the strata of the plastic clay of Sussex, the geologist will immediately recognize the usual characters of that formation, which, viewed on an extended scale, is composed of an indefinite number of sand, clay, and pebble beds, irregularly alternating, the distribution of the organic remains, like the alternation of the strata, being exceedingly variable. Sometimes they occupy the clay, at other times the sand or pebbles, and very frequently are altogether wanting in them both. Intermediate between that formation and the London clay. Geological Transactions, Volume 4, page 209. Professor Buckland. Residing within a short distance of Castle Hill, the interesting character of its beds had long since engaged my attention. But from want of leisure to arrange the notes I had taken, my observations have been anticipated by the gentleman above named in every important particular. Exposure to considerable danger. Specimens may generally be found among the ruins of the cliffs that lie scattered on the shore, from half a mile to a mile west of Newhaven Harbour, and was lying in a wharf near Lewes. See Mr. Sowerby's description of this substance in British Mineralogy. It probably has been introduced into its present situation by infiltration. Professor Buckland on the plastic clay. Geological Transactions, Volume 4, page 294. It is infusible at 166 degrees of Wedgwood. Kirwan. A partial combustion taking place during its fusion. History of the Gas Blowpipe by E.D. Clark, LL.D. Octavo, 1819, page 56. The experiments of my brother gave similar results. Water, 45. Phillips Mineralogy, 2nd edition, 1819, page 111. Is susceptible of a fine polish. In the elegant compendium of geology inserted in Professor Brand's Manual of Chemistry are the following observations on this subject. In the cliffs at Newhaven on the Sussex coast, a very curious series of changes is going on. A stratum of marl, containing decomposing pyrites, lies upon the chalk, which gives rise to the formation of sulfate of alumine. This is decomposed by the chalk, and aluminous earth, selenite, and oxide of iron are the results. Manual of Chemistry, 3 volumes, 8vo, 1821, Volume 3, page 312. In the Annals of Philosophy for August 1820, Mr. Cooper of the Strand gives a description of an aluminous chalybeate spring situated on the coast between Newhaven and Rottingdean. The precise situation of this spring is not mentioned, and my brother and myself have searched for it in vain. I can therefore add nothing to the following extract from Mr. Cooper's letter. Description of an aluminous chalybeate spring on the coast of Sussex, from the Annals of Philosophy, August 1819, Article 11, Number 80, page 148. '89 Strand, July, 1819. Dear Sir, I was requested to examine a bottle of water which was brought to me from the coast of Sussex, between Newhaven and Rottingdean, and although the quantity I had was small, being only about a wine quart, yet there was sufficient to ascertain its general nature and characters, without regarding the quantities of its component parts. The spring is situated, as I understand, about midway between Newhaven and Rottingdean, at an elevation of about 15 or 16 feet above the level of the sea at high water mark. It issues from between the cliffs or fissures of the chalk in small streams, and these when united pour forth from 20 to 25 gallons in the hour. The chalk about the place is everywhere tinged with an ochreous deposit. Its temperature as it issues is 65 degrees Fahrenheit, and remains constantly the same. When I received it, there was a deposit of a brownish colour, which proved on examination to be oxide of iron. Its specific gravity at the temperature of 60 degrees Fahrenheit was 1.076. It is slightly acidulous, changing the colour of litmus paper both before and after boiling, by which operation it deposits a further portion of oxide of iron, and also a little lime. Reagents show it to contain the following substances in solution: oxide of iron, alumina, muriatic acid, sulfuric acid, lime, carbonic acid, soda. This last substance I will not be quite certain of, but I expect shortly to be able to make a more perfect analysis, and to give a better account of its situation, which is of some importance, as I expect it is not far distant from the spot where the native alumina or subsulfate is found. I am, etc., John Thomas Cooper. To Dr. Thompson. Near Brighton Church, Goldstone Bottom, and Fulmer Hill. The boulders of this breccia, like those of the siliceous sandstone, were used in distant ages as sepulchral stones. Beneath one of those, near Brighton Church, an urn of high antiquity, containing human bones and ashes, was discovered by the late Reverend J. Douglas, F.A.S. An immense block of this kind is situated in Hove parish, near the Shoreham Road, and is vulgarly called Goldstone. From the British word coal or holystone, it is evidently a tolmen of the British period. This stone is in a line to the south of Goldstone Bottom, at the end of which, close to the rise of the hill, is a dilapidated cirque, composed of large stones of the same kind. On the farm of Thomas Reed Kemp, Esquire, opposite Wick, are 2 dilapidated veins, formed of similar materials, and on each side of the British trackway leading to the Devil's Dyke, blocks of the same substance may also be observed. Extract of a letter from the late Reverend J. Douglas to the author, dated May 1818. Formerly so abundant as to be used for fuel by the poorer inhabitants. Lee's History of Lewis and Brighthelmston, octavo, 1795, page 554. It is difficult to imagine from whence so large a quantity of this substance could have been derived. The narrow layer at Castle Hill is evidently too inconsiderable for the purpose, and no traces of it occur in any other part of the adjacent coast. The encroachments of the sea at Brighton are well known to have been very extensive within the last few centuries. It is probable that a bed of surturbrand formerly existed in the strata that have been swept away. Is it probable that a bed of surturbrand formerly existed in the strata that have been swept away? Or was the layer at Castle Hill at that period sufficiently extensive? Was it washed from the opposite coast of France, or from Alum Bay in the Isle of Wight? In the midst of testaceous remains decidedly of marine origin. Essai minéral géographique, page 126. With the vegetable fibers quite distinct. Geological Transactions, Volume 2, page 191. In the blue clay at Woolwich. British Mineralogy, Volume 4, page 185. Des mines supérieures de gypse. Géographie minéralogique, page 276, plate 2, figure 7. The only decided instance of a freshwater shell that has been discovered in that deposit. The fossil in question was submitted to the examination of Mr. G. B. Sowerby, who favoured me with the following observations. The specimen you have sent me has every character of a Serenay, and of being a freshwater bivalve. I would, however, suggest the necessity of extreme caution in noting the stratum from which it was obtained. If from the plastic clay, it is the first that I have seen decidedly from that formation, of a freshwater origin. All the fossils from the London and plastic clay being marine, this shell too bears considerable resemblance to some from Woolwich, as well as to a species that occurs abundantly in the stratum of melange between the two freshwater beds at Heddon Hill in the Isle of Wight. Marked Austria vesicularis. In a recent communication from Monsieur Brongniart, the distinguished geologist questions the propriety of this appropriation. He remarks that in the environs of Paris, the Austria vesicularis of Lamarck is confined to the upper, or flinty chalk. It is therefore probable that the English fossil belongs to a different species. Although organic remains have been noticed in it only at Reading. Professor Buckland on the Plastic Clay, Geological Transactions, Volume 4. 4. Alluvium. Professor Buckland on the Plastic Clay Formation, Geological Transactions, Volume 4, page 295. Very frequently are altogether wanting in them both. Geological Transactions, Volume 4, page 295.